Hello everyone, today we are going to repair the 5700 of 2 Southern Gems. These two cards are both second repair cards. The last one marked the fixed explosion phenomenon on it with a sticker. This one has no core power supply, and the fixed bomb of this one is a small probability that it can be lit and brushed through burrs. Let's repair this one without core power supply first to see if we can successfully win it. Before powering up, we follow international practice. First, let's measure whether the important voltage and signal to ground values are normal. 12 volts to ground value is normal. 3.3 volts to ground value is normal. The clock signal is normal for the ground. The reset signal is normal for the ground. Y12 volts to ground value is normal. The Y12 volt to ground value on the other side is normal. Let's take a look at what's going on. After disassembling, continue to measure. 5 volts to the ground value is normal. 1.8 volts to ground value is normal. 0.75 volts to the ground value is normal. The core power supply to the ground value is 0. This is also normal. VDDCR SOC value for ground is 2 normal. The VPP power supply value of the superficial layer is normal. The power supply to the surface layer is normal to the ground. VDC for land value is normal. It means that there is no noticeable short circuit in this card. There should be hope for repair. I carefully examined the appearance again. It was found that the main control power chip of the core power supply was replaced. Part of the second MOS here has also been changed. The 4 oblique control chips on the reverse side. 3 have been replaced. I took a closer look with a microscope again. This chip is welded well. There is a dark spot here. I found it to be a problem with the light. I observed the second MOS again. This one was replaced. This one was replaced. This one has also been replaced. This oblique control chip has also been replaced. This one. This one. The oblique control chip has been replaced. But there seems to be nothing wrong with welding. Let's measure whether the voltage is normal according to the store timeline. 5 volts normal. The 1.8 volt output is 0. Isn't it to reduce the leakage when I go here? We open the circuit diagram. It can be seen through the circuit diagram query. 1.8 volts are generated by U4515 control. Let's check the working conditions of this chip. First, measure whether the input voltage is normal. 12 volts normal. Then measure whether the opening signal is normal. The opening signal is 0. Query by circuit diagram. The 1.8 power on signal is controlled by the 1000. I ran the circuit. It was found that the 1000 corresponds to this hexagonal MOS tube. We just took it down. Above. 1.8 is already normal. The core power supply output is still 0. It seems that this card has more than one glitch. VDC SOC 0.9 is normal. Let's measure whether there is a ground short circuit at the output of the core power supply. Adjust the voltage of the regulated power supply to 1. Negative grounding. The positive electrode is connected to the output of the core power supply. The current is only 0.80. Pass this test. It means that there is no short circuit to the ground of the core power supply. I thought about it for a moment. Core power supply and VDTCR SOC. They are all controlled by this main power supply series. Now the VDTCR SOC voltage is normal. It shows that the important working conditions of the main control have been met. At this time, we should look it up. 35,217 output PWM signal. Is there a control for DMOS on? In order to be able to quickly lock faults, we use Infineon Zeros Programmer. Let's read the working status of 35,217. We go through the SMB bus on the chip to communicate with Infineon Zeros Programmer. For ease of welding, the SMB bus of the 35,217 is connected to the CHV1003. This places the port of the CHV1003. I have the programmer connected. Here the USB icon turns green. Indicate that the connection was successful. Search for chips. You can see that there are 2 voltages coming out here. The first voltage output is 0. The second voltage output is 0.9. This is also in line with our test just now. We place the mouse in the position of the first voltage. Now hint at pH. Indicates that the output phase is wrong. It can be seen through here. It is the third line that is reporting an error. The third line bit corresponds to pump 3. That is, the third corner of the chip. The pump 3 input voltage is 1.6. This is not normal. Normally, it should be around 0.38. I found out while measuring. The C point of the third style corner is a bit unfull. I observed it again with a graphical mirror. I found this corner a bit abnormal. It was not as I expected. This horn has been broken. The corner next to it has been crooked. Let's take a look at the pads. This silver horn is obviously a little less sucking than other silver horns. We look for a brand new 35,217. Shout it up. There is still no core power output. VWASOC output is also 0. Isn't this getting worse the more you repair it? Don't panic at this time. Let's go back to this new chip. Write the program and you're good to go. Open this software again. The USB icon here is green. Indicate that the connection was successful. Then click Program. You can see that you can already check it here. Check the procedure. Write a program. The gray color here represents the successful program write. Then measure the internal pressure. 0.9 is already normal. VES-ISOC is also 0.9. The video memory power is 1.35. VES-I 0.9. The voltage is all out. Let's put it together below. Let's see if it can be lit. I've put it together. Boot. The screen lights up successfully. So because of this movie management chip of yours, the interior is with a program. We are replacing it. Be sure to write it to the corresponding program. Alright. That's it for today's video. If new animations are needed to learn, you can send me a message privately. Remember to like and follow. Thanks for watching.